Hello and welcome back to the Introduction to Finance YouTube channel. Today I'm building off of one of my previous videos, which was a bond example using annual coupons. And here I'm going to be showing you the time value of money equation and also the time value of money function, now for a bond with semi-annual coupons instead. So we're going to see what changes between the two versions. Now here I have a few of my inputs. So I have face value is 1,000. 3-ish maturity remaining, the coupon rate is 5%, and the yield to maturity is 7%. Now, most bonds in the US do pay semi-annual coupons, so this method is more applicable to when you start getting into the bond market and calculating clean and dirty prices. So let's look at our timeline and fill in our cash flows. I'm going to start in the same place I did on the annual coupon bond with this face value of 1,000. So at the end of this bond, I am going to receive my $1,000. Nothing about that changes. So that's the first cash flow I'm going to add. Next up, I need to figure out the interest I receive each period. So every 6 months, I'm going to receive one of my coupons or my interest payment. So I need to figure out what that payment is going to be, and that's going to be based off of this coupon rate that we have. So again, I have that same coupon rate equation. That the coupon rate equals the annual coupon divided by the face value. So what I can do here is I can take the coupon rate times the face value, so move this over to the other side, and then that's going to give me what the annual coupon is. So my annual coupon is $50. But in this case, I need a semi-annual coupon, not an annual coupon. So what's nice about the bond market is all you have to do is now take this number and divide it by the number of coupons per year, and that gives you your coupon payment. So my semi-annual coupon is equal to $50 divided by 2, or $25. So now I'm going to add that $25 every 6 months to my timeline. Next up, I have the equations that I'm going to be using to solve for that bond price or the bond value at time 0. So we're trying to figure out what all of these cash flows are worth to us today. So let's start with each one of the coupons. So each one of these coupons can be grouped together and discounted back. So we have a constant cash flow, a fixed amount of time, and each one of these cash flows is evenly spaced on our timeline. So what I could use here is an annuity formula. And because I'm taking these cash flows backward on my timeline, it's going to be the present value of the annuity. Now next up, I have the $1,000 here at the end. So this $1,000, I also want to figure out its value at time 0. So I'm going to discount that one backwards again. So it's a present value. And here's just a single cash flow. So now I've matched up each one of my equations to what I'm solving for. So we have the present value of an annuity equation, and then we have the present value of a single cash flow equation. Next up, we need to figure out what each one of these inputs is going to be. So where I start is with this coupon. So the coupon determines the frequency of all of the inputs. So this coupon is semi-annual. So that's the first thing I'm going to fill in. So I have a coupon of $25. Now when I fill in the rest of this portion, I need to make sure everything else is measured semi-annually as well. So let's start with the T. So for the T, in the annual coupon version, that was the total number of payments, or in that case, the total number of years. Now here again, it's going to be the total number of coupons, which in this case is the number of years times 2. So I like to think of it as the number of coupons. So here I have 1, 2, 3, 4, 5, 6 coupons total. So my exponent's going to be -6. Then lastly, let's look at this R. So the R needs to be the rate in between coupons. So what that means is I don't want a 1-year rate, I want a 6-month rate. What's nice about the bond market is that when they give us this yield to maturity, this yield to maturity is what's called a bond equivalent yield. So I'll write that down here. The yield to maturity is a bond equivalent yield. And what that tells us is that the yield to maturity is equal to that periodic rate or the semi-annual rate times 2. So now all I want is that semi-annual rate. So I can say that the semi-annual rate is equal to the yield to maturity divided by 2, which would be 7% divided by 2, or 3.5%. Now that 3.5% is my R value. So let's go through all of those inputs one more time. So I started off with the coupon. So the coupon was $25 and it was paid every 6 months. So because this was a 6-month coupon, I now needed my T to be the total number of 6-month periods, and then my R to be my 6-month rate. So for my T, I have 3 years, 2 coupons per year, so a total of 6 coupons. Then for my R, I know that the yield to maturity, which is where I get my R from, for 1 year is 7%, but that one is a bond equivalent yield, which is similar to like an APR. So really the yield to maturity is the semi-annual rate times 2. So to get that semi-annual rate, I can take my yield to maturity divided by 2 and end up with 3.5%. So that becomes my R. Now that we've done the annuity, we're going to repeat the exact same thing for the single cash flow. So I'm going to add on my face value of 1,000 divided by 1 plus, and here again, I want to use that semi-annual compounding because I have a semi-annual rate. So I'm going to have 1, 2, 3, 4, 5, 6 periods. So my exponent will be 6. And then my 6-month rate is 3.5%. So in both of these equations, you want to be doing everything on a 6-month basis. Now when I add both of these together, for the first one, you're going to end up with around $133.21. The second term, $813.50. So in total, I end up with $946.71. Now let's look at the graphing calculator version. So where I'm getting each one of these inputs from is on my calculator. I go to Apps. Then you want to select that first one, Finance. Press Enter. Again, it'll already be highlighted for time value of money solver. Press Enter. And now we have a series of inputs. So we're going to go through each one of these and label exactly what it would be for a bond with semi-annual coupons. So our N value, that's going to be the same as T. So that's going to be our number of 6-month periods, which you can also think of as your number of coupons. Now our I, this is essentially like that R value, but when you type it in, you want to make sure it's in percentage form, not in decimal form like we use for the calculator or for the equations. So I want this one to be my 6-month rate, which is my yield to maturity divided by 2, 3.5%. Next up, present value. So that's what we're solving for. Payment, that is my semi-annual coupon. FV stands for future value, which is our face value in this case. Then down here at the bottom, we have P over Y, which is payments per year, and then compounds per year is C over Y. I leave both of those as 1. I never like to change those. What I change are the inputs up top instead. Then last up, we should have end highlighted, because on our timeline, each one of these cash flows happens at the end of each period. So filling in numbers now, my number of 6-month periods for this is 3 years, 2 periods per year, or 6. My I want my 6-month rate, so that's going to be my yield to maturity divided by 2, so 7% divided by 2. Type it in as a percent, so I'm going to type in 3.5. Present value is my price, skip over that for now. Payment is what I'm solving for. So here, payment is my semi-annual coupon. So payment is going to end up being $25. FV is my face value, so that's going to be 1,000. So now I'm going to go over to my calculator and start typing these in. So my N is 6, then I'm going to press enter. I, 3.5, enter. PV, you can see that there already is a price in there. Just leave that in there for now. Or if you have 0 there, you can just skip over it. Just press enter again. Payment, 25, enter. FV, is it going to be 1,000? I already have 1,000, but I'll just type it in again there. I'm going to leave that as 1, 1, and then you can see that end is highlighted for me. So that's exactly what I want. So now I'm going to go back up using my arrow keys to PV. And now I want it to be hovering on present value. And the function I want to use now is this solve button that's right above the enter key. So how I actually end up clicking on that solve is I'm going to do alpha, or the green button, then press enter. And then it's going to solve exactly whichever one you're highlighted on. So this one's going to solve for present value and give us a number, which is 946.71. And you'll notice that is a negative number. The reason that is a negative number is because calculators and Excel think about all these problems in terms of cash inflows and cash outflows. So we're basically buying a bond for $946.71. So this one is negative because it's a cash outflow. Then we're going to receive our interest, and then we receive the $1,000 at the end of the bond. So both of these are positive because they're cash inflows. The calculator needs one or the other to end up being negative. That way the problem works out. So I hope you found this video helpful. Again, the annual video will be linked down below. And I'm also going to link down below this same problem, but instead of solving it on a graphing calculator, I'll solve it on a financial calculator. If you have any video requests, please feel free to leave them down below, and I'll see you next time.